This is an introduction for the basic trigo that you'll be learning. So for the basic trigo, so let me just introduce a calculator button first. So you should be able to locate these three buttons on your calculator. So let me introduce the pronunciation first. So when you see this button, right, we pronounce it as sign. So not the common one that people will think sin. It's not a sin. Okay, so we call it sign. So this one we'll pronounce it as a cosine. And this one is not a tan. We pronounce it as a tangent. So this one is like these three words is going to represent three different ratios. And the ratio will come from the length in a right angle triangle. So at the end of this idea, right, so you will have three formula. Okay, so these are the three functions that comes out with three formula. So what will the three formula do? So these three formulas are ratios. The ratios are usually not written as the primary school ratio. We don't write the ratio like this. We're going to write the ratio as a fraction. Okay, so the fractions that you see, right, are ratios. So they express the ratios as fraction. So what are we using this for? Okay, these three ratios are used to calculate length and angle. So we are calculating length and angle in a right angle triangle. So if you still remember your Pythagoras theorem also calculates length, and it is also applicable in a right angle triangle. So remember this. So it is the same idea. So in a 90-degree, we can apply Pythagoras theorem to find length. But Pythagoras theorem only help us to find length. So in trigo, we got three ratios to help us to find length and angle. So this formula will involve three angles and the three length. So this formula will involve the three angles and the three length. Okay, but usually the angles will be the angles has to be in a right angle triangle. Okay, so let me introduce the notation first. You'll find very weird notation. Okay, but one of the most important one will still be your hypotenuse. So remember the hypotenuse was important in Pythagoras theorem. So the hypotenuse is the one we label as C. So right now, the hypotenuse, we use it as a H. So it will still be the longest length in the right angle triangle. So the other two lengths during Pythagoras theorem, you just label it as A and B, is your choice. But right now, we cannot label it A and B in any way that you like. Your labeling actually depends on the location of your angle. So I'm going to do it as, so X is the angle. So we read it as sine X, cosine X, tangent X. So this is the angle that we're talking about. So can X be on the other corner, right? Yes. Okay, so I'm just showing you first. So you locate the angle X. This is the O. O is the length that is opposite the angle. So O is the length that is opposite the angle. A is the length that touches the angle. So unlike Pythagoras theorem, you can label your A and B accordingly. Anything that you like, but right now here I got to label according to the position. So O stands for opposite angle. A stands for adjacent to the angle. Adjacent means it is side by side with the angle. So the ratio will be, the sine ratio will be O:H. The ratio of opposites over hypotenuse. But again, the O:H, we express it as a fraction. And then A/H is for cosine. But the ratio, we're going to express it as a fraction. Okay. Then O/A, we express it as a fraction as well. So these three, right, these three formula, these three function explore the ratio of opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So for a start, you will feel that it's very, very confusing. It's very difficult to remember. So that's why they come up with abbreviation. They come up with an abbreviation, hopefully to help you remember the ratio. So the abbreviation is like this: S/O/H. Cosine C/A/H. Tangent T/O/A. So they use the abbreviation. Hopefully you can see the three formulas or the three ratios clearly. Okay, so will my O and A will change if I relocate the angle. So I'm going to show you a sample. So if right now, I'm going to put my angle here. If I put my angle here, this length will be the opposite because it's opposite the angle. This length will be adjacent because it's touching the angle, whereas the 90 degree doesn't change. So the hypotenuse doesn't change. So can you see if I change the angle, the O and A will change. So the O, because O represent opposite the angle. If you change the location of the angle, of course, the opposite of the angle will change. A is adjacent to the angle, so obviously it will change according to the location of the angle. So this will be the a bit confusing part. So the O and A will change depending on where is your angle. So whereas 90 degree doesn't change. So you might feel that Pythagoras is a lot easier because you can label your A and B differently. But here your O and A must stick to where the angle is. So that is just an introduction on this idea. You will need more examples to understand how will this be three different formula and how can this formula helps you with calculating length and ratio. So for the first one, for a start, you got to learn to press calculator first because this will be three new buttons to you. So for example, how are you going to press sine 25? So you press your sine button and you press your 2 and 5. It should return you a value. But some of your calculator may have a bracket. So if any case, if your calculator has a bracket, you make sure you insert the bracket and close the bracket. So here 4SF. So try to learn to press the button. This is the first time you press this button. And you should discover something about this. Every time you press this button, your answer is quite ugly. You will see a lot of decimal. So which means, right, in this topic, when you're finding length, the length is usually not very nice. So such a situation, we will round off to 3SF. Okay. So there's also, then how are we going to find the angles? Later on, we'll do bit by bit. So the first thing is understand that there's an opposite length, understand that there's an adjacent angle, okay, understand that there's a hypotenuse. And you got to understand the ratio that's being written as a fraction. And then you got to try pressing out. So you cannot detach the angle from the function. So this one is like, so sine 25, right? It's like a whole unit. You cannot detach it. Okay, so in case some of you end up detaching it. So when we say sine 25, it is a unit. So when we say cosine 68, it is a unit. It is glued together. You cannot separate it. So sometimes some people can have wrong thinking. So tangent 49 is 1 unit. That means we want the ratio of 49 degrees. Tangent ratio of 49 degrees. So you cannot split it up. Okay, so otherwise, if you have this like weird idea that I want to split the 68 and from the cosine, you will find this whole topic doesn't make sense. So it will take you a while to understand that these are 3 formulas. These 3 formulas is based on angle and the ratio. And it will facilitate you to calculate the length in the right angle triangle. So these 3 formulas sometimes will work hand in hand with Pythagoras theorem. In a question, exam question, length can either be found by Pythagoras or by the 3 formulas. So do make sure you press the calculator and you have the same numerical value as me.